While totally solar energy powered home energy systems are quite expensive to install, passive solar systems are much more economical. Many passive solar features can be incorporated at the time of construction with a small additional initial cost to a conventional system. These features enable energy costs to be 1/2 to 1/3 of the cost in conventional homes. Below is the cost analysis from the case study of Esperanza del Sol. A. Write the cost equation for the conventional system. Let's first of all identify the costs that are involved. The cost of installation of a conventional system is $10,000. The additional annual energy costs for the conventional system are $740 per year. So we have the initial cost of $10,000 plus the variable cost of $740 per year. So our equation will be C is equal to the fixed cost, which is $10,000, plus the variable cost, which is $740, multiplied by the number of years that the system has been installed. For part B, we're asked to write the cost equation for the passive hybrid solar system. So let's first of all identify the costs that are involved. First of all, we have to install a conventional system. Then we have to install the additional passive solar features. And then finally, we have the annual energy cost of the hybrid system with the additional passive solar features. So the $10,000 and the $150, those are one-time cost. And then the variable cost is the $540. So together, $10,000 and $150 is $10,150. So our equation will be C is equal to $10,150 plus 540 multiplied by N. In part C, we're asked when would the total cost of the passive hybrid solar system be the same as the conventional system. So in other words, we want to determine when is the cost of the conventional system equal to the cost of the hybrid system. Well, in order to find out when this will occur, we need to find the value of N. So we need to substitute expressions for the cost of the conventional system and the cost of the hybrid system. And we have those expressions up above in parts A and B. The cost of the conventional system is 10,000 plus 740 N. And the cost of the hybrid system is 10,150 plus 540 N. We need to solve this equation for N to determine how long it will take for the two systems to have the same cost. So let's take away 10,000 from both sides. That will give us 150 on the right hand side of the equation. And we'll take 540 N away from both sides, and that will give us 200 N on the left side. Finally, divide both sides by 200, and we get 150 divided by 200, and 150 divided by 200 is equal to 0.75. So after 3/4 of a year, the total cost of the passive hybrid solar system will be the same as the conventional system. So our final answer is 0.75 year. For part D, It says after 5 years, what would be the total energy cost of the passive hybrid solar system? What would be the total cost of the conventional system? Well, we simply need to substitute 5 into each. So the cost of the passive hybrid solar system can be determined by using our equation from B. So we'll have C is equal to 10,150 plus 540 multiplied by 5. That comes out to be 12,850. So the cost of the passive hybrid solar system is $12,850. To determine the total cost of the conventional system, we can substitute 5 for n in the equation from part A. We get C is equal to 10,000 plus 740 multiplied by 5. The total cost is 13,700.